Zoom session is being brought to you by the Fractal Heart of Gold forming. All right. Systems of inequalities. An inequality, well, it'd be something like this. Minus 3x plus 7y is greater than 21. It could be a greater than sign. It could be a less than sign. It could be a greater than or equal sign or a less than or equal sign. All right. The graph of an inequality like such as this is a set of points on the plane fitting the inequality. And if you have a linear inequality such as this, you'll get as a half plane. Now, for example, minus 3x plus 7y is greater than 21. This is a strict inequality, greater than, not greater than or equal. And because of that, we exclude the boundary line. We denote that by dot, 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 dot. And then, okay, because it's a line, you could find it by finding where the boundary line is a line. We could find it by finding the x and y intercepts. So for example, if we set x equal to 0, then this term cancels and get 7y is greater than 21, and therefore y is greater than 3. So here's 0 by 3, and y is greater than 3, so it's everything above this point. If we set y equal to 0, then minus 3x is greater than 21, so x is less than negative 7. So here's the point negative 7 by 0, and x is less than that, so we point to the left of it. So, and then we draw the boundary line between those points, dot, 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 dot. And we color in the half of the plane which these two arrows point into. This half, the upper left half. And this is the graph of the inequality. Here's 2x minus 3y is less than or equal to 9. Because this is not a strict inequality, it's an unstrict inequality, I guess we could call it, we include the boundary line, and we'll denote that by a solid line. And because it's a line, we find the intercepts. When x is 0, minus 3y is less than or equal to 9, so y is greater than or equal to negative 3. So here's 0 by negative 3, we include that, and we include everything above it. When y is 0, 2x is less than or equal to 9, so x is less than or equal to 9 halves. Here's the point 9 halves by 0, 4.5 by 0. We include that and everything to the left of it. We draw the solid boundary line between them, and this upper left half of the plane is the half that these arrows point into. X squared plus y squared greater than or equal to 100. Now this is not a linear inequality, it is a quadratic. In fact, we had an equal sign, that's a circle with radius 10. So the boundary line is a circle and is included. Greater than or equal means that radius at least 10, so everything outside the circle, and that is the graph. Now, if you have a system of inequalities, we have several inequalities such as this, and we'll find the overlap or the intersection of each inequality. And if you graph a system of linear inequalities, we get an intersection of half planes, which will generally be some kind of polygon. Here, x plus y less than or equal to 4. So 0 and y is less than or equal to 4 here. And x is less than or equal to 4 by 0 here. So here's that boundary line, and we point downwards and to the left of it. Y greater than or equal to x, that's the boundary line, y equals x, and y is above that. And we've colored in the quarter of the plane, not a half plane, quarter of the plane where all the arrows point in. This half of this quarter of the plane. Not here because this is pointing away, not here because this is pointing away, and not here because both of these are pointing away. Please, when you do these problem sets, do not give me a plane with 3/4 of the plane colored in. Please don't do that, because I'll mark an X. And it's not much better to have one of them sort of cross-hatch this way and the other one cross-hatch this way and this one double cross-hatch. Please don't. We're talking about the intersection of two half planes, not their union. So please don't do that. So, okay, this quarter of the plane. Here we have, it's not linear. Y less than or equal to 9 minus x squared, whose graph is everything below this upside down parabola. X greater than or equal to 0, that's the right half of the plane. Y greater than or equal to 0, that's the upper half of the plane. So you want the intersection, the overlap of all three. So it'll be this quarter of a downward pointed parabola. So let's hit the parabolic end. Here's to the right of the y-axis. Here's above the x-axis. This. Here is a linear system. X greater than or equal to 0, y greater than or equal to 0, x less than or equal to 5, and x plus y less than or equal to 7. X greater than or equal to 0, well, here's the line x equals 0, and we make some little lines pointing to the right of it. X less than or equal to 5, here's the line x equals 5, and you make some arrows pointing to the left of that. Y greater than or equal to 0, here's the line y equals 0, and point some lines pointing above that. And here's x plus y less than or equal to 7. Well, okay, that's a diagonal line like this. It goes through 0 by 7 and 7 by 0. Because it's a less than or equal, we can prove that we have to point our lines below and to the left. So I know, so okay, between these 1, 2, 3, 4 lines, we have divided the plane into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. Which part to color in? Well, the part that all the arrows point inwards to. This points in, this points in, this points in. So this quadrilateral is what's called the feasible set for this system. Unfortunately, I can't really go much further. This is one of those topics where the book sort of does a halfway job, and really I think you should either do it completely or not at all. This is part of something called linear programming. The idea is that we'll be given a set of constraints such as this. So x and y have to be in this plane. I want to maximize or minimize something called an objective function, such as, let's say, 3x plus 2y. Turns out that that maximum and minimum occurs at one of the corner points of the feasible set. And there are a number of problems we could work out with that. And linear programming was developed at during World War II as a way to maximize production and thus defeat Hitler, and which I think is an eminently practical thing to do. But like I say, they don't really get into it fully in this course, just get into it halfway. But okay, here we are. We have concluded the section for today. Let us stop recording. Here goes.